Hello, everybody. Welcome to the LIUniverse. I am, of course, your host, Dr. Charles Liu, and whether or not you feel a little shy about it, don't hesitate to call me Chuck.
Oh
It
boy.
is such a pleasure to be here today, absolutely, because as always, I am filled with joy to hang out with my co-host, Allen Liu. Hey, Allen.
Hello, everybody.
Hey. So, any auditory manipulations of unusual sounding things that you've done lately?
Oh boy. Somebody was recently bragging to me that they figured out how to vocode people. So I was trying to figure that out as well on Audacity.
And
Works
did it work?
reasonably well. It worked
Okay.
reasonably well.
All right. If we were to vocode me, what tune would you put underneath, you think?
Ooh, I don't know, man. I will give a old spoiler that the person who was showing this to me used Gangsta's Paradise. So
okay. I've been spending most of my life. Okay. Lovely.
Oh boy. Yeah. So for people who don't know what vocoding is, it's when you take someone's voice and like you tune it onto an audio track of something else. It's very hilarious. People use it for memes a lot. Yeah. Don't know how that happened.
It's my joy to be today here on the LIUniverse. Like something like that.
Yeah.
Okay. But that is a perfect segue in because our guest today is not only just an astrophysicist of great repute, but also has so much to tell us about like music and art and cool stuff of all kinds. I am so happy to welcome to the podcast Dr. Charlotte Olsen. Hi, Charlotte.
Hi. Thanks for having me.
Oh, it's my pleasure. And if I were to try to call you something other than Charlotte, what nickname would I use for you?
Well, a lot of people have tried to call me Charlie, but I really don't like that. And really, most of my friends, most of my friends actually call me Chuck. So,
Woo! All right.
Now we have two Chucks.
What?
Yes.
We can distinguish. We'll figure it out.
But only to our friends, right?
So. Right.
True. Yeah.
Well, that's wonderful. Now, Charlotte, you are at the City University of New York, like me, but on a different campus, right? And so different borough, different everything. And you've come a long way by many different paths. Tell us a little bit about what you're doing, where you are, and just a tease of what we'll be talking about today.
Oh, yeah, absolutely. Thank you. So, I am a postdoc currently, and I am at City Tech, which is the CUNY that's in downtown Brooklyn.
Awesome.
And yeah, I love it. It's delightful. There's not great food options right next to it, but that's okay. Of course, I'm very food motivated. This is exactly what I'm going to think about. But I am an LSST Catalyst Fellow, which is a very, very long way of saying that my postdoc is part of I'm working with the Vera C. Rubin Observatory.
Yes.
Oh, nice.
Well, the survey that goes for the Vera C. Rubin Observatory. And so a lot of my science is really centered around using those data that are coming out. And
amazing.
Like other Chucks, I'm really interested in galaxy evolution.
Yes.
And in the past, I've really been I am very, very excited about very small galaxies, like dwarf galaxies, and also looking at what's happening on the inside of galaxies if we break them up into little pieces.
I love that. That's fantastic. And we will get into that assured. But first, of course, it is time for the cool, joyful thing of the cosmos today.
I feel like you're just trying to come up with new ways to mess it up at this point.
Does it sound like I'm doing that?
It sounds pretend. A little like that. You don't have to pretend.
All right. All right. What is it again? It's the
joyfully cool cosmic thing of the day.
Joyfully cool cosmic thing of the day. Yes. Well, you have to admit, this is a joyfully cool cosmic thing. It is
sure
the loudest gravitational wave signal ever detected. All right.
Yeah.
Let me give a little background for people who are talking about it. You guys have heard of the LIGO scientific collaboration, which, of course, was able to detect the sound wave traveling through the universe of two black holes crashing into each other more than 1 billion light years away from Earth. And that was about half a dozen years ago.
Yeah.
And
I will say that it's the gravitational waves aren't quite the same as the literal sound waves.
That's right. It's very important to keep that in mind.
It's a distinction. Right? Yeah.
So it's a wave in space. Like if you drop a rock into a pond, you have ripples in the water. When those two black holes collided, it was like they created ripples in space itself.
Right. Yeah. Because sound waves, it's moving through stuff within space.
Yeah.
So there's been science even that like looks at sound wave like phenomenon with like gas between stars and things like that. But in gravitational waves like this, what's happening is that space-time itself is doing the rippling because gravity distorts space-time the way Einstein's been, elucidated for all of us.
Yeah, it is pretty amazing. And
it's pretty epic.
This most recent announcement, just very recently, was a detection that happened more than a year ago, not just with LIGO, but also with other collaborations that were also detecting gravitational waves around the world. And by doing that, they were able to be even more precise, by a lot, actually, than what happened in 2017. So in 2023, the object or the event is called Gravitational Wave Event 230814. So August the 14th, 2023, this event happened, and the measurements appeared to show that this was caused, this ringing of the universe, by a black hole of about 30-ish times the mass of the sun, combining with another black hole about 30-ish times the mass of the sun. And they're coming together to form a single black hole that is about 60 times the mass of the sun, released an entire sun's worth of energy by E equals mc squared. And it just, imagine our sun just suddenly being converted completely into energy. Okay. And then all of that energy is pulsing through the universe, and it finally reaches us hundreds of millions of light years away. And the amount of rippling that it does to our space-time is less than 1/10 the diameter of a proton.
Yeah.
But we saw it. And it is the amazing thing about the universe that we could actually observe it to that detail. Charlotte, you have to tell us about these black hole collisions. These aren't exactly supermassive black holes, but they're more massive than our sun. Does this happen a lot? Is this something that affects your work and our study of galaxies in general? Should we be on the lookout for something like this happening in our neighborhood?
I think we absolutely should be. Intermediate mass black holes are probably all over the place, and we wouldn't be able to necessarily detect smaller things colliding. But everything seems to be like falling towards one another and colliding in general. Now that we can actually figure out that there are these supermassive black holes, and even like the neutron star mergers, which are really exciting,
right?
Those kind of things happening, then it does really hint that there's a lot more going on. The thing that I find really exciting about a lot of the LIGO stuff is that we are able to now, when we see these ripples in space-time from these arrays of interferometers where you've got very precise mirrors and lasers that are measuring these slight shifts in space-time that are so small that you could have followed these up for multi-messenger astronomy.
Right.
Where
Amazing.
you have you can basically say, ooh, we felt a wiggle. Everybody go look. And so everybody will
see if there's light coming out from the same spot or neutrinos or whatever.
And
that's awesome.
I think, especially now. So you were saying with this paper, this is so incredibly precise because there are so many. Now there's the two LIGOs. There are other there are other gravitational wave detectors all around the planet. And because of that, we can actually triangulate location and tell people,
I love
hey,
that.
we think that something really intense happened.
Wow.
We think it happened over there. Could you go look? And normally you can't really do that, right? And if we don't have a full array of, we should continue to fund LIGO is what I'm saying.
Yes, we should 100%
Oh,
need to.
yes, absolutely.
Oh, man.
Oh,
Yeah.
well, the
Yeah.
funding of science right now is really an interesting question, which we'll touch on a little tiny bit. But I want to really focus on the beauty of the science itself. Now, when
Yeah.
you're studying bits of galaxies, like little galaxies making big ones, or the little bits that are still inside galaxies, do you have to take into account black holes and their collisions or their presence or anything like that? How do they affect galaxies as we understand them?
So, when I'm thinking about very small galaxies, I don't think about black holes too much. There are black holes in dwarf galaxies a lot of the time, but they are very tricky to detect because it's usually the big ones that are the loud ones.
Makes
Um,
sense.
Yeah. And also, the loudest of all of them are outside of my area of science because
Oh,
AGN are like the loudest, brightest, shiniest, most exciting black holes that you ever
So
could. Like
AGN
they,
standing for active galactic nuclei.
yeah, sorry about that. The active
No, all
galactic
good.
nuclei of a galaxy where you've got this massive black hole that is just like feasting on all and then spewing all of this energy out. And that's really important, especially in, when galaxies are forming and evolving, because that can blast off all of the, and heat up all of the gas that normally would be potentially forming stars. Um,
hmm.
but when I see those in the real world, I go, oh, that's contaminating my sample. I just want to look at
Oh.
the boring galaxies.
That's fair. That's
Because
somebody else's
yeah,
priority there.
yeah. Ew.
One
So,
one astronomer's treasure is another astronomer's trash to some extent.
exactly.
I
I'm
love that.
terrible.
Yeah. Yeah, I mean, LIGO is a really
Mhm.
cool thing, isn't it? I mean, if you really think about it, but it is very different from the kinds of astronomy that we have traditionally done, where we're collecting light as
Right.
our main thing, right? So I think it's kind of neat.
I think it's neat. Yeah. I have a fun extra bit about the LIGO collision that we were just talking about a few minutes ago.
Oh, yeah.
When I was reading the sort of abstract opening of the paper there, what
Mhm.
I saw was that it's not just so cool because it's louder than everything else, right? That it is the loudest collision, but what's extra cool about that is that means we can pick up on the harmonics of the collision.
Oh.
So yeah, so when we're trying to like you're hearing a tone, right? So something
Mhm.
from like a pitch. So that could be something like middle C or the A above middle C or something
Mhm.
like that. Those are the bass frequencies changing, so how fast the waves are coming at you. Um, but what we can also hear now because this collision was so loud is the harmonics on top of that. So that's sort of the difference between like a clarinet or a piano or a flute.
Oh,
We can hear
wow.
like the shape of the wave beyond just how fast it's coming at us.
So we're just not hearing only the sound of the explosion. We're actually hearing the harmonies in the
Yeah.
universe that's coming
Yeah,
out
the
from those
Harmonia
things.
Mundi, right? Yeah,
Wow.
and so what's cool about that is that means it can tell us like what shapes the black holes are making as they're colliding with each other. And this is sort of the best evidence that we have through gravitational waves that the models we have of what black holes do in terms of physics actually match the black holes in the universe that we're looking at.
Amazing. I love that. That's fantastic. So I think it's great. Okay, but I just got to ask you then, Charlotte, if these things are actually contaminants or irritants to you, what is the stuff you actually want to see? I mean, what do you want to get? What would be your gold if you were doing your research on some galaxies?
Oh, goodness. I mean, I'm really excited about seeing the faintest ones. So
Uh,
being able to pick
mm,
up just the littlest, faintest galaxies. And the other thing that I think would be really, really exciting to see is to be able to see some of this, like see more of the structure that galaxies live within. So many of them are
ooh.
kind of flowing through these large structures of gas and other galaxies and dark matter, and being able to know exactly where those are. This is, I mean, at this point, when we're talking about LIGO, this feels very pedestrian to say I need more photons, but at the same time, I need more photons.
You got to get more light.
Okay. Yeah. But I mean, honestly, like the multi-messenger aspect of it is just, it's so exciting because that gives us a really much bigger sense of like whether our models of how things are forming when we have these like major mergers of galaxies, like whether those are accurate, and also like how often those are happening. Because I like to think about like major mergers a lot. So major mergers as in somewhere close to the same size, but realistically, most of the time when a galaxy is growing by accreting more mass onto it from like taking other little galaxies, it's like usually other little galaxies, not two big galaxies crashing together, right? But how often do two big galaxies crash together?
That's a great question, because the Andromeda Galaxy and our Milky Way galaxy are going to have a major merger, we think, in about 5 billion years. So I want to get back to that. But first, let's take a quick commercial break. And going out of the break, I'm going to do some primary tone of some collision. You guys do some harmonic tones. We're just going to create something. Okay. All right. We'll be right back with the LIUniverse after this tone. Go. Hey, everybody. We are back on the LIUniverse, and we're ready for a question from the audience for Dr. Charlotte Olsen. Alan, who do we got?
All right. So we have a question from Joe. And this is a perfect one because it's a galaxy-related question here.
Okay.
What does it mean for the Milky Way to have a bar? Why does it have a bar? And how can such a long bar form? I presume they're not talking about, where you go and get shots
Milky
of
Way bars?
Synthahol. or Milky Way bars.
Synthahol. Oh my gosh. For those of you who are on the YouTube and can see this, Charlotte's background looks like the holodeck.
Yeah, that's why I brought it up. It
which
looks
is so amazing.
like the holodeck.
If you guys,
that was never my intention with this,
no,
but I'm all for it.
Yeah, I'm 100% in support. If you guys are just listening, go on the YouTube, take a look and see what we're talking about.
Please do.
I think it's just an amazing thing. Yeah. So yeah, Charlotte, tell us about this. This is obviously not the Milky Way bar that like I buy at the local drugstore. This is a Milky Way bar. Right?
Milky Way bar. It's not where astronauts go to drink, right? It's, so Milky Way has a bar. A lot of spiral galaxies, disk galaxies, spiral galaxies, a lot of them do have bars. And bars, like there are people who just study bars and spiral galaxies, and they are so cool. I think that there's some of what I've seen recently is there's a lot of like really interesting debate into how stable a bar is, because you should be able, if you put enough angular momentum into your galaxy, you should be able to, maybe create this bar that's in there, and the way that it stirs up the stars in there is going to really, really like transport a lot of material around the galaxy. Also, where star formation is happening, like you can have additional compression at the ends, almost as if you've got like big ice cream stir where you have that additional stuff that's happening there. So they're very, very cool. And I think for a really long time we used to think that bars would only form a lot later after a galaxy had kind of made more of itself and accreted more stuff over time and had more mergers, that you would finally get a bar in there. But I think because of what we're seeing with JWST and with a lot of new surveys as well, people are seeing bars a lot earlier. And the implication is that bars are actually pretty stable and they can hang out for a long time.
Wow.
So the bar is always open.
Yeah.
Hey.
These that's good. These bars are not solid. They can shear, right? They're just collections of stars that just happen to form a very long line that's thousands of light years long.
Right in the middle of everything, too.
Yeah,
right?
Which is really surprising to me. But what you're saying about ice cream stirrers is really interesting. when you're saying about angular momentums, you're basically taking whatever dynamical activity and spinning this whole disk full of stars and gas and dust in a way, and lo and behold, a straight line pattern shows up. I mean, that
Yeah.
seems impossible, because
Yeah.
a stir must surely, like in our drinks, at our Milky Way bar, where we're stirring a chocolate martini or whatever, right? It's all turbulent and messed up. How can it organize so well? I mean, that's a really good question to me.
Yeah. Honestly, I don't know if I know why it's exactly in a perfect straight line. But if you look at a lot of these bar structures
Hmm.
and things like that, there are like kind of peanutty shaped ones that sometimes you find,
Oh,
or different boxy ones. These structures that are centered kind of around the like the galactic bulge, that
uh-huh.
are these like kind of larger structures that they exist because of there's some sort of like extra density, over density, that has this layer of compression
Hmm.
that is there. But
Yeah. Okay.
the really strong, I think we have a pretty strong bar structure for the Milky Way.
Okay.
That's
Like
cool.
it's honestly, I don't know. I've seen I've only seen parts of it, so
Okay. That's all
Yeah,
right.
that's fair.
I
I
don't think
mean,
everyone's seen.
it's funky because like we're in the middle of the Milky Way, so it's actually hard to figure out how the rest of the Milky Way looks compared to like how the Andromeda Galaxy looks. Because the Andromeda Galaxy, you just like point a telescope at it, or even like your eyeball with a sufficiently dark place, and you can just look at it.
That's
Whereas
right.
the Milky Way, we have to like do all this fancy radial velocity parallax
Mhm.
funky stuff to try and map out exactly where all the stars are, so that we could get a sense of this shape because we're like stuck inside of it. I
Yeah.
love that. Like that's
No,
just one of the cool things I think.
I think that's awesome. I want to build right on your comment, Alan, about dark skies, because I know for a fact, Charlotte, that you have come from a place where the skies are some of the darkest in the country, if not in the world, right? Give us a little bit about like how your like background and so forth got you into astronomy, and the path that it took to get you to studying all this cool stuff about the universe.
Oh, yeah, no, I'd be happy to. So I have seen a little bit of the Milky Way, what can be seen from the Northern Hemisphere.
Hmm.
Okay.
Where I was growing up, it was Northern California and up amongst the redwoods.
Oh,
So
nice.
where the trees, the trees only give you like this much sky kind of to look at.
Yeah, because they're so tall.
Because they're so tall. So if you like, it's the like if you like really like looking directly up, then you're completely set. But it was wonderful when I was a child, seeing the Perseids in the summer. The skies were pretty dark, even though um the seeing wasn't always great because of the humidity there. So it's not like one of the most perfect places in the world to see.
Hmm.
But, the fact that you can go out on a clear night and be able to see part of the Milky Way, not necessarily be able to trace out the bar or figure out, like, from the radial velocities of the stars exactly where in the Milky Way they are,
Hmm.
but, that was a huge inspiration for me when I
Cool.
was growing up.
I love
So,
that.
so did astronomy become a hobby for you from a very early age?
Um, I th that's a good question.
I don't want to
I
stump you on
wasn't
anything hard.
so I
So,
wasn't one I wasn't I'm still not one of those people where if you say, "Well, tell me what that star is," I'm gonna be able to tell you.
ah,
I did run
Interesting.
some public telescope nights when I was an undergrad, because I went to school, there when I went to school,
hmm.
um, and got a little bit better about that, but I was definitely the kid that was reading all of the sci-fi and reading every science magazine I
I
could
Oh,
read.
love
I
that.
So
love that.
I was more I was a little bit less experimental and a little bit more theory at the time. So
Oh, that's
I may have
great.
flipped to being more of an observer now,
No,
actually.
that's wonderful. So you got techie at some point in your childhood. You were messing with things and reading and thinking like that. Wow. And then now you're here. And you know, we can be astronomers whether or not we've memorized all the constellations. I'm a firm believer in that, right? Just asking questions about the universe is what matters. Uh,
Yeah.
so you wound up doing something that was not astronomy for quite some time before you wound up becoming an astronomer, right?
Yeah, yeah. I actually have had 1,000,001 jobs before
Really?
doing this,
Amazing.
before
Tell us
pursuing.
three. Tell us three.
Okay. All right. So, I worked at a record store for like 10 years.
Wow.
I worked like doing behind the scenes like broadcast stuff for public television, public radio.
Oh,
I did
great.
food
Wow.
service.
Oh,
used to serve pizza.
hey.
Hey, we
There are
love
other
pizza.
ones. Oh, I was a venue booking manager for shows for
Oh,
live music at one
superb.
point. So yeah, I kept busy
Yeah.
and I kept the lights on.
Hey, it
Oh, I
worked.
think
It
that's
worked.
marvelous. So,
Yeah.
so if you worked in radio and TV, you didn't become a radio astronomer.
No, no, I
No.
did not.
But
I did not.
yes,
But
but it, yeah.
I was very good with with operating all of the dishes. So it would have been a
Wow.
natural uh transition, but that's not what
That's
happened.
totally wonderful. But you worked in a record store. Does that mean you were a musician too?
Yeah, actually, so this was
Aha.
kind of my saving grace
Oh,
when
no
I was
kidding.
young. Yeah, yeah. So I loved one of the things that really got me through like my younger years was kind of the salvation of live music. So I
Oh,
used to always go to a lot of like kind of underground and garage shows and things like that, like all of the all
ooh,
ages shows that were like benefits to get the kids a skate park and things like that. Those
That's
my
so
wow.
favorite
nice.
things to do, just go listen to the music and get lost in it.
Oh,
And
wow.
somewhere around then I started playing bass and playing music with some of my friends.
Hey,
That's
And
cool.
hey.
it was great. It was and it's something that I still absolutely completely care about, but it's something I mean, honestly, like if you're you when it comes to like astronomy or music, um all right, I'm not going to make some broad sweeping statement. This is for me.
Oh, you can
For
if you want to. That's fine.
but when it comes to any of this, like being able to pursue something that you really care about, being able to like have the like guts to pursue something that you are passionate about and get
Mhm.
lost in something, it really requires community. And
Mm.
I think
Mm.
that's one of the lessons that I learned from like playing music is that you kind of you can do it, but you can do it like all by yourself and not share it, but if you make yourself uncomfortable enough to actually do it with other
Yeah.
people and in front of other people, then
Oh.
it creates a structure that's like really supportive for you.
Oh, I love
I
that.
love that. Yeah,
That
there's
makes
actually
so
a
much sense.
yeah, there was a we have a listener question that's sort of in that same vicinity also,
Oh,
which
oh, bring it
might be
on. Bring
good
it on.
to
Yeah.
just bring up right now that we have this conversation.
Sure. Go for it.
Yeah, so this question comes from Shivani, who is asking, how do you mix music and science? I can't decide if I want to be a scientist or a musician someday. Can I be both?
Oh, you are the perfect person to answer that question, Charlotte, having been both. Oh, talk to us. Talk to us.
Yeah, definitely you can do both. Honestly, I think it would be preferable to do both. Like it's never a good idea to completely the problem with astronomy is that, like when you become an astronomer, you become an astronomer.
Hmm.
When you are making pizza, you do not become a pizza chef unless you choose to define yourself as that. But like
That
with
makes sense.
astronomy, it is very much your identity gets tied to it. And so if you can have other aspects that are supporting you for when things get rough, like if
Yeah,
you are
fair.
having a bad day with music, you can invest you can invest your time into like your study of the stars and vice versa. And I know
That's
a lot of
great.
people who have done the same thing, and it doesn't have to be music. It could be like
Mhm.
I really like you know uh a lot of people do rock climbing. I don't understand it, but it's fine. Like there's a thing with physics and rock climbing. It's very
Ah,
confusing. I'm not going to investigate it. Don't really care. Don't want to know. But like there are all of these different aspects of our personalities, and I think we diminish a lot of them by calling them hobbies,
Mm.
and we also diminish a lot of them by only determining the label that we give ourselves is usually defined by like what it is that is paying the rent, right?
Oh,
Right. Yeah.
yeah.
So, like, you can, whether you are a professional musician or a professional astronomer or a professional rock climber, doesn't really
Mm.
matter, and it shouldn't diminish the passions that you have. And we shouldn't be necessarily be calling those hobbies. These are super important parts of ourselves.
Yeah.
Wow.
And I mean, I know
That's
in
so cool.
astronomy, there's a lot of people who like aren't professional in the sense that they're not getting this as their primary pay, but who do a lot of really great discoveries.
Mhm.
Yeah.
So
And are contributing massively to the field.
That's right. And we have plenty of astronomers, especially the ones that we've had here on the show, right, Alan, over all these
yeah,
years. Everybody has something cool that they do in addition to astronomy.
yeah,
Everybody does.
it's true.
Yeah. So we just want to rebrand that. Is that what you're telling us, Charlotte? Don't call them just your profession and your hobby, but this is what I do. I make some money from, and this is what I do that I don't make some money from, but it's still part of me. It's still who I am.
Yeah, I love that.
Yeah.
Oh, great. So tell us about the music scene where you are in Brooklyn. The coolest, well, people on my borough will be upset if I say that, but
Yeah.
purportedly coolest place for cool music, Brooklyn. Tell us a little bit about
It's got to be somewhere in Bushwick, and I don't
it.
live in Bushwick.
Ah,
I live
okay.
in Crown
Alas.
Heights. So
Okay.
this is the problem. I never get out anymore because like I'm now middle-aged. I'm like now healthily middle-aged, and I'm like I get home from work and I'm like, that was great. I am going to go to sleep. But yeah,
I mean, I do that
mean,
occasionally.
Yeah.
right?
And I'm healthily middle-aged, but I get home and I'm like, yeah, let's party.
Well, you have infinite energy somehow.
We all do it
You need
differently.
some of your energy. Yeah.
Yeah, it's like we have to find the source of dark energy. Maybe it's Chuck.
It could be,
Well,
or
maybe it's Chuck.
maybe it's Chuck, right?
Hey, yeah, double Chuck. Woodchuck Chuck.
Like if there's I mean, it feels like you've kind of like managed to capture all of the energy of merging black holes in order to like keep yourself energized throughout the rest of the evening.
Thank you, I think.
Yeah, I have not yet figured out how to do that. There is really really good stuff that's going on all over the place. I went to not a Brooklyn show last night, but I had to. But it was a big one. It was bands that I'm never going to be able to see again. It was Lena Lovitch and the B-52s and Devo all playing. But it was over in Long Island, so we had to like get on a train and then get on the Long Island Railroad and then take a. It was a pilgrimage.
That's so fantastic. I'm seeing Whip It Real Good and Working in a Coal Mine going right across my face together with Love Shack. I mean, wow,
that's amazing.
It was an incredible show. It was definitely worth it was a pilgrimage, but it was worth it.
That's great.
Try to make it out every once in a while for something that's big.
Great. Well, what's really cool about those kinds of things is that, unlike, say, if you're attending, say, a Taylor Swift Eras concert or something where you're seeing a musician at the height of their powers, right? You're seeing, this is what you're saying, almost a spiritual experience where these folks who have, through their recordings, been so influential in our lives, now we get to commune with them in that community that you were talking about to sort of bring all that together, right? That's so cool.
Yeah. Oh, it was a really great show. It was very nice. And I managed to make it back before like 4 a.m. after trying to get back from Long Island. So it was a good time. But one of the favorite things that my spouse and I do is there is a big Halloween show that happens here in Brooklyn. Actually, no, I lie. Because it's in the Knockdown Center, so it's in Queens.
Shout out to that other borough. Okay.
Yeah,
we've only got 2 of them left.
Yeah. But it's really good. They usually have some headliners on the main stage that are like, bigger, kind of like indie, like garage, like, people where you're like, oh my God, I can't believe you got so and so out of retirement for on
That's
the big
awesome.
stage. And they have like multiple different rooms that are completely set up. Um and it's all of like for the other rooms, for the non-headliners, it's all local bands that are dressed up and performing as classic
Oh,
bands.
Oh,
So
that's
oh,
cool.
I
it's
love
really
that.
fun.
Wow.
Um, when I was younger, I think one of the last shows that I played out for like a really long time,
Uh-huh.
me and some of my bandmates did the same thing for a Halloween
Mm.
show where we all
Ooh.
dressed up as this band, The Runaways,
Oh,
um, which
classic,
Joan
classic.
Jett came out of. So
Yes.
it's a fun time because then it's like you have cover bands, but it's like it's musicians that doing the
Yeah.
covers, and it's just for once, right?
Oh, I love that. That's so awesome. Uh, I am inspired, Charlotte. I go out and hear some live music while looking at the stars at the same time. I think that would just be the best. I can't wait. Wow.
It's great.
Okay.
Well, if you make it into Queens, we should go.
All right. All right. Let's compare calendar notes. All right. Alan, you too. Okay.
Yeah, I go to Queens every so often.
Yeah. All right. Let's make it happen. Charlotte, time has flown by. We only have a few minutes left. I want you to tell me about one cool discovery or research area thing that you're doing right now that you want to share with everybody. Something really, really neat. Something maybe you've just published or something you're just about to publish. Something really cool.
Okay, so I have one.
Oh,
So,
an evil
um,
laugh. I have one.
uh,
Hmm.
so I've been looking at a few of a few of galaxies. These are like, disk galaxies, spiral galaxies. Um, None of them have bars. Hmm. But
Hmm.
it's a handful of these galaxies, and I've been looking at them in multiple different wavelengths. And I love
Awesome.
doing SED fitting, which is spectral
Mhm.
energy distribution fitting. It is
Ooh.
just a fancy way of saying I have the picture of the galaxy in a bunch of different colors of the rainbow, and I am fitting a line to it to imagine what it would look like if I were to smear out the light, like from a prism or something, right?
Okay.
Yeah.
And then if I have those different pictures in different colors and I can fit that, then that gives me an idea of what, from models and things, what might be underneath the hood of that
Mm.
galaxy. Because I
Oh,
could compare it to another spectrum that I've got and say, well, this one I made and it's got this much dust and this many stars, and these are the ages of the different stars in there, right?
Mhm.
And so you can kind of do that sort of inference. All right. So anyway, that's my
Yeah.
passion project with SCD fitting.
Uh-huh.
But I did this where I broke up galaxies, a whole bunch of different little points,
Mm.
and
oh,
said, let's look at these little different areas, and then let's figure out what the SCD for each of these different areas is. And then
Oh.
from that, let me see if we can figure out how that little area has been growing over cosmic time.
that's amazing.
But it's neat because, like, we were talking earlier about, like, bars and, like, stellar mixing and things, like, that are happening, like, dynamically in these galaxies.
Mhm.
But if I can say, "Hey, I know over here, the stars maybe, like, aren't forming as much as they were, like, in the past,
Yeah.
but over here, they're forming a little bit more than they were in the past."
Oh,
Then
cool.
that might give you an idea of kind of what different processes are affecting the galaxy, like across the galaxy. Like maybe
Completely.
there's something outside of the galaxy, some gas or something that's doing something to this. Or
Wow.
like maybe I don't know, maybe there's no AGN in these, so it's definitely not any kind of feedback thing that's happening. But
That's
we're trying
so
to figure
awesome.
out what the subtleties are that are happening in there.
Yeah.
So I'm really excited about that.
Oh, it's
And
fantastic. It's like measuring the aging process of each galaxy, but not just as a whole, but like every single part. What is the
yeah.
hand doing? What is the heart doing? What is the foot
Hmm.
doing? What is the
I
liver
love
doing?
that.
Ah, it's such a
Yeah.
beautiful view of a galaxy and its aging and its evolution. I love
Yeah.
that. That is
I've
totally
been
awesome.
pretty obsessed with it. So it's actually, the paper is like, it's it's gigantic, but it's worth it. So keep an eye out on the archive.
We'll love that.
Oh, this is so good. Charlotte, we have so much more to talk about in the future. I hope you come back, okay? And especially once you've got the secret to all of the aging of all of the galaxies, you let us know, because I want to know. Okay.
Yeah.
Awesome.
I think that's marvelous.
I would love to know that too.
Thank you so much, Charlotte. Hey, if we want to find you on the internet, the social media world and so forth, where can we find you and your work?
So I'm on Blue Sky, and you should be able to find me on Blue Sky. My Blue Sky handle is at Charlotte Eureka, and it's all one word. Eureka,
like Eureka, California, right?
Well, that's where, I know. It's the double meaning. It's like I've discovered things, but then also like I grew up in Eureka, so so now you know. But yeah, you can find me there. I also have like a GitHub page, Charlotte Olsen, github.io. For my,
we love GitHub pages.
I've got a GitHub page for myself. It's my placeholder for right now. I need to update it. So yeah, but I think I'd love to hear from anyone.
Wonderful. Anybody who has a GitHub has to update it. I think that's just...
yeah. I had to update mine recently.
Congratulations. All right. Well, Dr. Charlotte Olsen, thank you so much again for being on here. Come back sometime, okay? Thank you.
Yes. All right. Thank you. Thank you so much for having me. This was wonderful. Thank you.
Oh, my pleasure. And as always, our co-host, Allen Liu.
Yeah.
Thank you so much, as always, for everything that you do for this show.
Hey, glad to be here, as always.
And thank you in the audience for being with us for this episode. If you've liked what you've seen and heard, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.